Now, focusing on case one, which involves making the trimetozine, we actually notice that first we need to use a specific type of reactant, which is morpholine, and morpholine is going to be used with another type of compound, which is known in this case to be a form of methoxyl that is actually three of them attached around in a specific aromatic ring, and this aromatic ring on the other side will have a specific form of a carbonyl but has chloride attached in there. So now some of you may be asking, why do we need this complex compound in here? This compound, by the way, is actually called 3,4,5 trimethoxyl benzonyl chloride. And this particular compound, why, is because it has some specific segments that are going to be crucial within this particular compound that will be used to create a really definite and, I would say, appealing product in here. And this product here will need to be created from this compound alongside morpholine. And morpholine, take note here, will have two regions that are competing. One has nitrogen present in this particular ring, and the other is oxygen. And so therefore, what you're asking yourself is this: which one of these two particular heteroatoms are really good nucleophiles, which means which one has the electrons to be looser than the other in order for it to be willing to donate electrons to one of these segments in this particular ring. And what we notice is that the nitrogen indeed has a looser electrons or looser lone pairs to be able to act better as a nucleophile compared to that of the nitrogen. Therefore, as a result, it finds the electrophilic part within this particular ring in here, and the electrophilic part within this ring is a carbonyl region, which is the carbon specifically right here. And therefore, as a result of that, we are able to perform our specific nucleophilic attack, which then causes the bonding pair here to reform the bonding pair right here. But take note here that by reforming this particular pi bond, we actually cause a good leaving group, which is in this case chlorine, to leave. Therefore, this particular good leaving group leaves, and as a result of that, what we have is the loss of our chloride, and we create our specific intermediate product, which is seen right here. Now, take note here that this particular nitrogen will have a positive charge. Therefore, by introducing a base, which in this case will be a particular hydroxyl group, this hydroxyl, which has a negative charge, will act as a base, and this particular lone pair on the nitrogen picks up the proton, thereby deprotonating this particular compound here, which is around the nitrogen region. And therefore this bonding pair here becomes a lone pair on the nitrogen, and therefore this creates our specific product. And where on this side we have the loss of water, we have our desired product that is being formed right here. Now, take note that our product that is created here has a specific region which you've noticed here to be called an amide. And so this amide is really an interesting region in mind when we can actually lead to further reactions down the road, and that is where we're going to focus on our previous videos. But in here, this particular product here overall is called, take note, Trimetozine. And this trimetozine has a couple of interesting impact or application in pharmaceutical chemistry, and one is that this is not to be a sedative, and this sedative is or has been used since this specific region, which is in Europe, since the year 1959 in Europe, and this is actually used for the treatment of anxiety. And so these are the key themes that are really crucial for we to be able to create this particular type of compound that is not only easy to make by just using a trimethoxyl enzyme benzoline chloride, but also using morphine to create our specific product by performing a type of reaction which we notice here to be called an SN2 reaction to produce our specific product, which is what we have right here. So on our next video, we're going to look at case number 2, which is making cyclizine using our specific alternative or derivative of our piperazine, which will have in this case methyl attached instead of hydrogen in this particular region right here. So thanks for following me through this. Really appreciate it. Hit the comment down below, let me hear your thoughts. By that way I can talk to you soon. Stay smart as always and believe in yourselves.